In today's video, we shall take a closer look at static friction and kinetic friction. We shall see when they will act on a specific body, the difference between these two frictional forces, and also how to calculate them. So let's get started. Friction, which is a type of force, acts always opposite to motion. That means assume that we have a box like that, resting on a very rough floor. We start to push this box to the right. The moment there is a force that is trying to push the block to the right, a friction would start to act in an opposite direction, resisting that push. This happens although the body is still at rest. The same thing happens if I try to push this block to the left. So this is the force that I apply to push the block. At the same time, there will be friction that acts towards the right because this force is trying to create a motion to the left, so friction always opposes that motion. Therefore, it acts to the right in this case. More accurately, this friction here acts over there between the surfaces of the block and the floor. So this type of friction, the friction that acts on a body at rest, that resists potential motion, is known as the static friction. And this is how we write it, F with a subscript S. The value of this static friction depends on the magnitude of that push. If you're pushing the block while it is at rest with, say, 10 newtons, the block isn't moving, so the static friction at that moment is also 10 newtons, opposing that F. If you slightly increase it, let's say to 15 newtons, the static friction will increase to 15 newtons. To 20 newtons, it will also increase to 20 newtons. But this does not go on forever. There is a limit. And that limit depends on two things. The first thing is the so-called coefficient of static friction. This is characterized by how rough the surfaces between the block and the floor is. And this is a number. For example, you can take 0.4, 0.5, and so on. The rougher that surface, the higher this number. And this coefficient of static friction does not have any units. The second thing is the normal force that is acting on the block from the surface of the floor. Let's call it capital N, which in this case exactly the same as the weight of the block. Let's say the weight of the block, just as an example, is 50 newtons. So the normal force in this case, it is also 50 newtons. So the maximum value for static friction is given by the product of that coefficient of static friction times the normal force acting on the body. So in this case, if you take the coefficient of static friction to be, say, 0.5, this maximum limit for the static friction that is acting on the body is 0.5 times 50 newtons, which is 25 newtons. So now the question is, what happens if you push this block with a force greater than 25 newtons, say 30 newtons? The moment this push force becomes greater than the maximum static friction, then the static friction will cease to exist and the block will start to move to the left. So for that reason, we write the formula for static friction in terms of an inequality. It looks like this. It can be anywhere, start from 0 or slightly above 0 to be more accurate, all the way to a maximum value given by that expression mu s times n. Or, in our present example, that maximum value is 25 newtons, which is obtained by simply multiplying mu as the coefficient of static friction with the normal force. Now we know this block will start to move in that direction. What kind of friction acts now? The friction that acts now is known as the kinetic friction, because this is the friction that acts when the object is moving. So now the object is moving to the left, so kinetic friction acts to the right, opposing motion. Now what is the expression for that kinetic friction? Kinetic friction is given by an equation. It's mu k, a constant, times the normal force, the same normal force, 50 newtons in this case. Now this mu k is known as the coefficient of kinetic friction. It is also a number, a pure number without any units. It could be, say, 0.2, 0.3, and so on and so forth. So again, if the surface is rougher, the number is higher. So in this case, let's assume we want to calculate the kinetic friction. All we have to do is to take mu k times the normal force. So let's assume the object is moving and it's moving under the influence of 30 newtons. So this kinetic friction is given by mu k. Let's, in this example, take mu k to be 0.3 times 50 newtons. And you get 15 newtons. So in this example, when the push force is 30 newtons, the kinetic friction is 15 newtons, and the object is moving, the net force is, of course, 30 minus 15, which is 15 newtons. So that is the net force acting on this block. So there it is. The static friction is given by that inequality, and kinetic friction is given by this equation. Static friction is a type of friction that acts on a body when the body is at rest. Kinetic friction is a type of friction that acts on a body when the object or the body is moving. Let's look at the following problem. A man is trying to pull a 500 Newton crate. So that is the crate. Its weight is 500 newtons. To get it started moving, he has to pull with a horizontal force of 250 newtons. So the force F, when it's 250 newtons, the object will start to slide, about to move. Once the crate is moving, it takes only a force of 200 newtons to keep it moving at a constant speed. Find the coefficients of static friction and kinetic friction between the crate and the floor. So let's do the coefficients of static friction first. Now we know that maximum force of 250 newtons is required for the object to just about to move, and at that moment the static friction is maximum. That is the idea, and we know the expression for the maximum static friction. It is mu sub s, the coefficient of static friction, times the normal force. Let's look at the forces that is acting on this crate. One is the force that is applied by the man, which we know to be 250 newtons. And then you have the weight of that crate, which is 500 newtons. And then you have this normal force from the surface of the floor to the crate in an upward direction, which is also 500 newtons. So that is the normal force. And then you have the maximum static friction that acts in an opposite direction to that of that 250 newtons that is being exerted in a rightward direction. Since the maximum static friction occurs when F is 250 newtons, so the value of maximum static friction is indeed 250 newtons, and that equals to mu sub s times n. N is 500 newtons, and you can solve for the coefficient of static friction, which is 250 over 500, which is 0.5, and that's the answer for the first part. Now the coefficients of kinetic friction. Now we know it only takes a force of 200 newtons to make the crate to move. So now the crate is moving to the right. That means there is kinetic friction acting to the left. And we know the value of the kinetic friction is given by mu k times the normal force. Because the crate is moving to the right with constant speed, that means the acceleration is 0. So the rightward force must be the same as the backward or the leftward force. So in this case, it must be the same as 200 newtons. So mu k is 200 over the normal force, which is 500, and you get 0.4 for mu sub k. So the coefficient of kinetic friction is 0.4, and that solves the problem. Problem 2. A block of 5 kg is pushed across the ceiling using an 85 Newton force at an angle of 60 degrees with respect to the horizontal. The coefficient of kinetic friction between block and ceiling, so that means there, is 0.3. What is the magnitude of the block's acceleration? Let's look at the free body diagram. So you have this block, and you have that ceiling right there. So you have 85 newtons acting like that. That is the applied force at an angle of 60 degrees with respect to the horizontal. You have the weight, which is 5 times gravity, because we know the mass is 5 kg. Now there is this normal force like that, and there is this kinetic friction like that. And the block is accelerating rightward with an acceleration a. It's important to note that in this case the normal force is not the same as the weight, because there is an additional push from the y component of that 85 Newton force. What do we mean by that? The 85 Newton force has two components. The x component, which is 85 times cosine 60 degrees, and the y component, which is 85 times sine 60 degrees. If you take that direction to be x and that direction to be y. So let's apply Newton's second law in a rightward direction. Because the acceleration is rightward, the net force is also rightward. So the net force on this block equals that minus kinetic friction. So 85 cosine 60 degrees minus kinetic friction. And that must be the same as mass times acceleration. According to Newton's second law, mass is 5 kg times acceleration. So let's write the 5a there. What is kinetic friction? Kinetic friction equals mu sub k, the coefficient of kinetic friction, which is given to be 0.3, times the normal force. Now what is this normal force? There are two forces that contribute to the normal force. One is the y component of that 85 newtons, and also the weight. So since the normal force is in upward direction, so that normal force is 85 sine 60 minus the weight, which is 5 times gravity. So that is how you calculate the normal force. In this example, substituting this in here, you can solve for the acceleration. So the whole equation becomes 85 cosine 60 degrees minus 0.3 times 85 sine 60 degrees minus 5 times gravity equals 5 times acceleration. And you can get your acceleration. And the acceleration turns out to be 7.03 meter per second squared. And that solves the problem. Thank you for watching.